So this is the second question. We are given the probability of x1 equal to 0 and x1 equal to 1, and we are given the general conditional probability expression for p of xk plus 1 equal to 0 given xk equal to 0. So we have four general expressions here for k plus 1 equal to 0 and 1 and k equal to 0 and 1. So in the first subdivision we are asked to find the probability of p of x2 equal to 1. So to get p of x2 we put k equal to 1. So we'll use all of these expressions. By total probability theorem, p of x2 equal to 1 can be written as p of x2 equal to 1 given x1 equal to 0 into the probability that x1 equal to 0 plus p of x2 equal to 1 given x1 equal to 1 into the probability that x1 equal to 1. So substituting these values, so multiplying 0.4 with the probability that p of x1 equal to 0 and multiplying 0.7 with the probability that x1 equal to 1, we arrive at 0.64 for p of x2 equal to 1. So p of x2 equal to 0 is obtained by subtracting this from 1, so we get 0.36. In the second subdivision we are asked to find p of x3 equal to 1. To get p of x3 we substitute k equal to 2 in this expression. So again, by using total probability theorem, p of x3 equal to 1 can be found out as p of x3 equal to 1 given x2 equal to 0 using we are using these expressions into p of x2 equal to 0 plus p of x3 equal to 1 given x2 equal to 1, multiply that with the probability that x2 equal to 1. This is nothing but this follows the general form of this. This is k plus 1 and this is k, and here k is 2. So multiplying 0.4 with we have already found out p of x2 equal to 0 in the first subdivision. So multiplying 0.4 with 0.36 and 0.7 with 0.64, we arrive at this one, this 0.592. Now p of x3 equal to 0 can be found out by subtracting this from 1, and we get 0.408. In the third subdivision we are asked to find p of x1 equal to 0 given x3 equal to 1. We only know the expression, like we can get the expression p of x3 equal to 1 given x1 equal to 0. So this is an unknown expression which we cannot find directly. So we write this in terms of p of x3 equal to 1 given x1 equal to 0. So by expanding the conditional probability expression, we arrive at p of x1 equal to 0 given into x3 equal to 1 by p of x3 equal to 1. This can be written this way. Again, this is by Bayes' theorem, which with which we find an unknown value using a given value. And now to find p of x3 equal to 1 given x1 equal to 0, we can use the matrix method. So to find the general form of p of xk plus 1 given p of xk1, we can use this matrix method where this power of n is nothing but k minus 1. So here, sorry, k plus 1 minus 1, that is nothing but k. So this is the power of k. So here we are asked to find p of x3. So k is 2, so we raise it to the power of 2, all the four expressions which are given here. So we by squaring this we arrive at 0.48, 0.52. Now each of these values is p of xk plus 1 given that p of x1 is some value. So this element is p of x3 equal to 1 given x1 equal to 0. It comes out to be 0.52. So substituting 0.52 in this expression, p of x3 equal to 1 given x1 equal to 0, which we have found out here, substituting it in this, and this is given in the question, and we have found p of x3 equal to 1 in the previous subdivision. We get the answer to be 0.175. so this is how we find out an unknown from a known by an indirect method. Thank you.